Welcome to the next lesson in this chapter, where we are going to talk about system integration testing. And this is probably my favorite lesson of this chapter because it represents such a powerful way of testing your modular monolith. So let me start by explaining what a system integration test does. We were talking in the previous lesson about integration testing, and we were mainly concerned with testing a specific use case inside of one module. We would send a command or query, or maybe even call a respective API endpoint and then validate the result. With system integration testing, we want to verify the behavior between multiple modules inside of our system. So here's an example of that. We have a test that is going to send a register user command, verify that we get back a success result, and then is going to try to send the get customer query. And recall that this is being sent as part of the ticketing module. In this implementation, I'm going to poll using this query for a given period of time. The timeout is going to be 15 seconds, and after the timeout expires, we can either get a success result or fail because of a timeout. What's really interesting about this type of test is that it's going to send the register user command, which is going to execute the respective use case, but it will also publish a domain event. The domain event will be persisted inside of the database, and our integration test is also executing our outbox processor. That's going to pick up this domain event, publish an outbox message, which could lead to us publishing an integration event. And this means that we are testing the asynchronous communication between our modules. With enough time, the integration event will be consumed by the ticketing module, and we expect it to store a customer record in the database that we can query using the same identifier from the user result. You can see here I'm specifying user result value as the customer ID in the get customer query. Now you should understand what I mean by system integration test, and let me show you how we can write a test like this. You should go ahead and grab the latest version of the source code if you want to follow along with this lesson, because I introduced an Evently integration test project in the root test folder. I did this because I don't want us to go through the boilerplate again of setting up the Postgres container, Redis, Keycloak, and configuring the environment variables. In this implementation, I'm also setting up the interval in seconds for the outbox and inbox processors, and I'm configuring them to run every 5 seconds. This should be enough for our testing purposes, but we can adjust this value to be higher or lower if needed. I'm also setting up the test collection, the base integration test class, which configures our scope, the sender instance so that we can send our commands and queries, and I also have a command helpers class that I'm going to use in a later use case, but it just contains an extension method for the iSender interface, and I'm going to use it to send a create event command so that I can set up some tickets to test my add to cart functionality. And now let's go ahead and write our first test case. I'm going to add a new folder. I will call it register user, and inside of it I'm going to add a new class. Let's call it register user tests. This has to implement our base integration test. Let's go ahead and add the missing constructor, and now I can define my actual test case. This is going to be an asynchronous method, and I'm going to give it the name of register user should propagate to the ticketing module. And now let's go ahead and write our test case. The first step that we have to do is to register a new user. I'm going to define a register user command instance and specify some random data using Faker. Then I can go ahead and send this command using the sender instance. So let me specify the command, and this should return a result instance back. So let's call this the user result. And I first want to verify that the user result is success should be true. So this is going to register the user inside of the users module, and we get back a user result containing the user's identifier. Then I want to try to fetch the customer from the ticketing module. And to achieve this, I need to create a new query instance, and I'm looking for the get customer query. This is defined in the ticketing module, and I can specify the user result value, which contains the user identifier. Then I can use my sender to also send this query instance, and it should give me back the customer response. So let's call this the customer result. And now I can write my final assert statement, which expects that the customer result is success should be true, and also the customer result value should not be null. Now, if I go ahead and execute my test like this, you will see that it's going to fail. And this is because there needs to be a given period of time for our system to become eventually consistent, because we have an outbox processor and an inbox processor running in the background, and we have to accommodate for this. A very simple solution that I'm going to start with is by implementing a fixed delay between our two steps. So let's say I register the user, and then I can delay the execution of my test for a given period of time. For example, I can say time span from seconds, and I can specify 20 seconds, for example, and I expect that this should be enough to execute this command, wait for the outbox and inbox messages to be processed, and then we should probably be able to query the customer instance in the ticketing module. So let's go ahead and execute this test case. And you can see that after 22 seconds, our test has completed because our system has become eventually consistent and we are able to query the customer from the ticketing module. At this point, I want to do two things. First of all, I want to make a remark about the test setup. You don't necessarily need to have these environment variables in place. It's completely fine to use the values inside of the respective configuration files. For example, we can configure the interval in seconds for both the inbox and the outbox job to be 5 seconds, and this is going to also work for our tests. So let's use this simplified approach going forward. The second remark is actually having to wait 20 seconds for this test to complete. Imagine a code base where you have hundreds or maybe even thousands of test cases like this, testing the integrations between various modules, and how big of an impact you could have by waiting 20 seconds between every step inside of your test case. So a much better solution would be to implement polling here. So here's a simple example of how we could do that. Let's say I create a public static method. It's going to be asynchronous because I want to asynchronously poll for my data. So it needs to return a task. And let's say it returns a result, and I can specify that it returns a generic value. Then I can call this method poll and also specify the generic argument. And I need to pass in two arguments for this method. The first one is going to be a time span. That's going to represent the timeout, or how long we want to be polling for. After a given period of time, we probably want to give up and just throw an exception from this method. And the second argument is going to be a function that returns the result that we need. So it's going to be a task of a result of t. And let's call this an action. And then inside of the poll method, we can create a new periodic timer that's going to execute, for example, every 1 second. And I can also specify what is the end time for my test. So let's take the current time using UTC now and add the time span that we have specified as the timeout. So this is when we should stop polling and return some failure result. And then I can write a simple while loop saying that if date time UTC now is less than the end time, which you can translate as the current time is less than the time when you should time out. And the second condition that I want to add, which is why I introduced my timer, is call the wait for next tick async method. Of course, because this is an asynchronous method, we need to await it. And this is going to allow us to run this while loop every time our timer ticks, which is going to be every 1 second. And of course, you can adjust this to be more or less frequent. And then inside of this loop, we can just execute our action. It's going to give us back a result instance. So this is going to be a result of t. And I can say if the result is successful, stop polling and return the result instance. Otherwise, let's return some generic failure. So I can say return result. We can call the failure method, specify the generic argument, and I can say error null value, for example. This is an empty error instance that we have on the error type. So this would be our poll implementation. And then how we would use this is to replace this step here. So I'm going to add one more instance of the customer result. And then I'm going to take what we had previously that was querying the ticketing module. And then I'm going to say await poll, and I need to specify my timeout. So let's say time span from seconds and specify 15 seconds as the timeout. And then I need to provide a function that's going to implement our polling. So I'm just going to use the code that we already had. And of course, this has to be an asynchronous function. And this is going to fit the signature of the poll method. And now before running the test case, let's get rid of the task delay that we had from before. And let's execute the test case again. And this time you can see that the same test case completes in just 12 seconds using a polling implementation that's going to query the ticketing module every 1 second. This is a big improvement over the 20-something seconds that the test was taking in the previous implementation, and you can imagine how this adds up over a large code base. Now let me show you how we can easily introduce another test case. I'm going to copy the existing one, and I will rename it to propagate to attendance module. In this test case, I want to check that when we register a customer, it also gets propagated to the attendance module. So I'm going to run the get attendee query, and I expect to get back an attendee response. I need to update my test case slightly, and let's also rename this to attendee result. And this is very similar to the implementation that we had before. And now let's go ahead and run our 2 test cases. And while this is executing, let me walk you through what's actually going on in the background. This is very similar to what we discussed in the event carry state transfer lesson in one of the previous chapters. So the user will be registered inside of our system. This is going to publish an outbox message. This is going to send an integration event to the other modules in our system. The ticketing and the attendance module subscribe to this integration event, and when they process it, they're going to send a respective command to create a customer in the ticketing module and an attendee in the attendance module. And the integration tests that we are writing here are testing this exact behavior. So this is a very powerful way for how you can test the integration between the various modules in your system. Now I'm going to make a few improvements to our implementation. First, I'm going to add a static poller class, which is a helper class that's going to implement the method that we already had in our tests. And let's update our tests to use the poller. So I'm going to say poller wait async, and now I can get rid of this method here. And I also need to update the call in my other test case to use the poller helper class. As I said, this implements the same behavior, except I'm returning a timeout error to make it more obvious that our wait async method failed because of a timeout. And then I'm going to add another test case into the integration test project, and this is going to be the add to cart test case. Let's take a look what we have here. This is a bit more involved test case where we first need to register a user inside of our system, and this is a command in the users module. Then we are going to wait for this to propagate to the ticketing module, and we expect to get back a customer. Once we have a customer, I'm going to use my helper method to create an event and a respective ticket type, and then I want to test that I can add this ticket type into my cart, which is represented by sending the add item to cart command. I'm specifying the customer ID and the ticket type ID. So this is a more complex use case that involves a few commands and queries inside of our system, and let's see if this is also going to pass. And after a bit of time, you can see that all of our system integration tests are passing, including the add item to cart test case. Now, this test case is a bit more complex because it involves quite a bit of commands and queries being sent inside of our system. And this is an excellent way how you can test the integrations between your modules. The next steps would probably be to add more test cases. For example, after adding the item to cart, we want to check if we can submit the order, and a very interesting challenge would be to test the event cancellation flow, which is executed using an orchestrated saga. We can slowly wrap up this lesson about system integration testing, which is a way for us to test the integrations between our modules by running complex integration tests. These tests take a considerable amount of time to execute because we have to wait for our system to converge to an eventually consistent state. And I think this type of test is extremely valuable inside of a modular monolith. However, I would focus it on the most important use cases inside of your system, for example, the order placement and order payment, considering how long it takes to execute each test case. In the next lesson, we are going to continue our discussion about testing, and we are going to talk about automated testing in continuous integration and development pipelines.